Hello guys, so welcome back to my channel. Trust we are doing great. So today we're going to be doing justice to recursion. We've done the tutorial for this and I'm sure you've gone through the tutorial. Please do go through the tutorial. That's the 0x08C recursion task or project, but please try go through the tutorial so that you have a better understanding of this concept. Very important. I am going to put the link to the tutorial video in the description of this video, and like always there's a Google document also in the description of this video that contains all the answers to the task from task 0 to the last task. So if you don't have the time to go through the whole video, you can just simply go to the Google documents and try to understand the code and probably write out the code to your terminal. I don't advise you copying directly, just so you are able to understand what it means to code by yourself using your own hands. It's easier to think this thing is simple until you try to do it yourself, right? So please, it's advisable that you go through it before you can try to code this thing out yourself, type it out yourself, not just copy and paste. All right, very important. But I would love that you stay to the end, because I'm still going to be explaining the concept as we go along. So I would love that you stay to the end so that you understand this basic concept, because like I always say, the main goal of doing ALX is to know, not just to pass, is to know, right? So yeah, you pass the task because you want to go forward with the program, but you also need to know the concept. If not, then you are not a software developer or a software engineer. It's important that you understand the concept. So stay glued and let's do this together. So I have already created the test files, and I've also gone ahead to also just put in the file name here so that we don't go back and forth, because I am not going to be showing ALX intranet here. We'll just read out the questions and try to walk through the questions. So I'll advise you also go through your questions. All right. And I also have the main.h file here, which contains the prototype of all the functions we're going to be working with, and also the prototype of the putcar function. So if I vi, or let me just cat main.h, so you see we have all the prototype here. All the prototypes are here, including the putcar prototype, right? So you want to make sure you create your main.h file and then you include all the prototypes before you start working, so that it doesn't give you compilation error while you're trying to compile. So please try to include all your prototypes here. And then I also have my underscore putcar here, all right, which is what we're going to be using for printing to the screen. So you have to also make sure you have this out there, and then your readme.md file. These are the 3 files you need to create before you start your project. So a non-empty readme.md file that describes what this project is all about. Of course, you already know all these things, but I always just like to put it out there. And then lastly, I am not going to be pushing and using the checker because I'm not showing the intranet. So you want to make sure that when you are done testing your task and everything is okay, you need to git add, git commit, and git push, and then make sure you check your code to be sure it's marked done. And if the checker is not available as at the time you are doing this, you can manually click done once your result is correct. The most important thing is that you use the test file to test and your result is correct. So let's go to the project. We're going to be starting from task 0, and task 0 is just to write a function that prints a string followed by a new line. All right, so this is actually simple if we were using a printf or putcar to just print, but now we are doing recursion. So in recursion, you print things differently, unlike the normal just print a string and you can just go ahead and print a string. But here we do things a bit differently. So let's go ahead and open our file, which is the zero puts. So vi, and let me zoom this so that it's visible. Okay, so here I already have the prototype here. So all you need to do is just to copy the function prototype, just copy it to your terminal. Before then, let's document Betty for the sake of those that are still struggling with Betty. Of course, Betty is simple. I'm sure it should be simple right now. All right. So first we need to pick the name of the function, underscore recursion hyphen, and I will just say function name, but please you can do better with your description. And the next thing we need to do is to pick the parameter. So the parameter is x, and column I will just say parameter of the function. You can do better. And the next thing we need to do is I think this is okay. Without the return statement, this should work. Okay, so because we're just printing out a string. So there's a write a function that prints a string followed by a new line. Of course, we have been given the parameter x, which is a pointer. So now we're just going to write our code. So first you say if, so let's set a statement that we pick the terminating null byte. All right, so we don't print plus the terminating null byte. So if our pointer s is not equal to the terminating null byte, then we can go ahead and print a string. So we just say if it's not equal to the terminating null byte, if it's not equal to the terminating null byte, we just say put char, and here we can print a string, right? We can print a string. Now because it's recursion, if you do this, you're only going to print the first character of whatever you're trying to print, which is so let's say you're trying to print Sunday, so you're only going to be able to print x, right? You're only going to be able to print x, which is the character in the zero index. Now for us to be able to print the rest, we're going to call our function again. Remember when we're doing the tutorial, so we're going to call our function again, which is underscore puts underscore recursion. Now we will now pass the parameter name, which is x plus 1, right? So this will help us to print the remainder of the string. When you say print underscore putchar, is only going to print the character in the zero index, and then you call your function again. Remember, we say recursion is a function that calls itself. So you call your function again, and then you pass the remaining string, and this string is not equal to the terminating null byte. Now when you pass this, it's going to help you to print the remainder of this. Okay, so now let's go ahead and print the new line. So I will just say else underscore putchar, then we'll print a new line. Okay, I think this is all we are asked to do. So we print a string, and then we print a new line. So let's go ahead and compile our code. So we already have our test file here, which is 0 main.c. So you need to also create a main.c file. So let's go ahead and copy and compilation code. So let's go ahead and compile our code, hit enter, and let's check our code 0-puts, enter. So now check your intranet. You should see that you have the same thing puts in recursion. Why do we have that? Because that is what is passed to our main.c file. So 0cat 0 main.c. You can see that what is passed to it is put with recursion. That is the string that is passed to it. So that is what we have here, put with recursion. All right, so don't forget to git add, git commit, and git push. Now the next question 1, is write a function that prints a string in reverse. All right, so here we're going to print a string in reverse. So vi1, what's the task name? Okay, so here I already have the prototype or the function, so I will just document Betty. So underscore print rev recursion. So this is the function name. Sorry, I need to include yeah. So the next thing is to describe a parameter. I will just say parameter of the function. Parameter of the function. So let's just put a return statement. I'll say return a string. Okay. All right, so let's end that. Now let's look at our question. Our question says that we should write a function that prints a string in reverse. So let me pick out my paint and let me explain this. Now if you went through the tutorial, if you've gone through the tutorial, you should understand a bit of this already, but I will just try to explain it some more. Okay, my paint, is it working? Is it not working? Okay, my paint is, let me use this. Okay, so write a function that prints a string in reverse. Now normally in recursion we print in stack, something like this. So by stack we mean something printing on another. So let's say this is Sunday, right? Let's say this is Sunday. So if we're going to print Sunday, we're going to print it in stack, which is SUNDA and Y. So this is Sunday in stack, in recursion. So because we're printing in stack. Now, if we say we want to print this in reverse, first, if we call the function name, the function is going to arrange Sunday in this manner, like this, from XUNDAY, stack Sunday. So if we stack Sunday and we say underscore put car to print Sunday, it's going to print out Sunday for us like this. So now it's going to be Y A D N U S. This is what putcar is going to print for us. But if we call our function name, let's say the name of our function is str, which is for string, and then we call the function parameter, let's say function parameter is pointer x now, it's going to stack Sunday this way for us, printing it or stacking it from x u n d a y. Now if we call putcar to print this for us, putcar cannot access s without accessing u, and it cannot access u without accessing a, it cannot access n without accessing a, and all the way to y. So for us to be able to access what is done here, first we need to be able to print this. So first putcar is going to print y, and then print the next letter a, print the next letter d, the next letter n, the next letter u, the next letter s. So putcar is going to print it this way for us. So this is exactly what they want us to do, that we should write a function that prints in reverse. So first we're going to invoke the function name, call the function name, okay, which is if recursion calling itself, and then after that we will print it out, we will have it in reverse. So let's go ahead and do this. So now we will set a condition that says that if our function prototype is not equals to the terminating null byte, then go ahead and print the string. So let's set that. So if x, which is the parameter, is not equal to the terminating null byte, what should happen? If it's not equal to the terminating null byte, what should happen? It should go ahead and first call on the function, which is print all right, and then let's pass the parameter, which is s plus 1. So s plus 1, and then now let's print the string now using underscore putcar. Using underscore putcar, we'll print the string. So here putcar is going to print whatever is in the 0 first. In this case, what is in the 0 is y, and after printing in the y, in the 0 y, it will print the remainder, which is x plus 1. All right, so this is, I think this is all we need to do here. All right, and we can just go ahead, save and exit. So make sure to check Betty. Forgot to check Betty. Okay, Betty is fine. Now let's compile our code. Okay, something is wrong somewhere. Let's check our code and see. I didn't go through that error message, but let's just see what is wrong with our code. So if x is not equal to the terminating null byte, okay, this is supposed to be pointer s. Yep, supposed to be pointer s. So let's go ahead and run our, okay, that's fine. and then let's check our code. One dash print. Okay, so now you see it's printed in reverse. So if we check cat1 main.h, so this is what was passed to the string, and this is how it's been printed. So from the last letter R, E, K, L, A, all the way to the first letter C. All right, so that is how to print recursion in reverse. Okay, so let's go ahead and look at our next question. Our next question is question 2. So VI 2. Let's check for our question. Okay, so here we have it. Question 2. Question 2 says that we should write a function that returns the length of a string. And then it says the standard library also performs or gives us the same thing. So we should write a function that prints the length of a string in recursion. So here we are working with recursion. So for us to be able to do that, first we'll have to set a statement to check for the terminating null byte. And if we do that, by the time we check that, we then say, okay, now return the length of the string that is not equal to the terminating null byte. So let's go ahead and see how we can write this. So X. So I already have the prototype here, so let's go ahead and document Betty. Sorry. So our function name strlen recursion. So we just say function name, and our parameter s, say function parameter, and do we need to return anything? Yes, so let's just put the return there. So let's just say return a string. Okay, so let's write our code. How do we write this code to check for the length and count the length of the string? So here we are counting the length of the string. So first, let's set a statement and say if our function pointer, or the pointer, is not equal to the terminating null byte. If it's not equal to the terminating null byte, okay, I'm just trying to make sure that this looks better. Yep. So if it's not equal to the terminating null byte, we're just going to say return if it's not equal to the terminating null byte. That is, we've checked. Of course, you know how we check for this. We check for it and it's not equal to the terminating null byte. So we just ask the function to return to us so it should just return to us the character. So let's say, okay, let me write this, then I will explain this. So 1 plus, and then call the name of our function, which in this case is strlen underscore recursion, and then we're going to pass in the remainder of the string, which is x plus 1. Yep. So now count whatever you have first. So if it's not equal to the terminating non-byte, first return the first character in the index, which is index 0, and then plus call the name of the function and pass the remainder from index 1 to the end without the terminating null byte. This is simply what we are asked to do. This is simply what we are asked to do. And once that is done, we can just say, return 0. So you can say return 0. So it's not without the return 0, yeah, code is still going to work. Okay, so let's compile our code. And let's run our code. Okay, 14. So let's cut our two main.c and see what is there. So the string that was passed, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is correct. So with part 14, so that is correct. So that is how you can get the length of the screen and get it print a string and get it printed to your terminal. All right, so let's go ahead and look at the next question. The next question, that is question number 3, says that we should write a function that returns the factorial of a given number. That we should write a function that returns the factorial of a given number. Okay, so of course you already know what factorial is, right? Let's say we have let's say we have 5 factorial. Yeah, I explained something like this in the tutorial. Let's say we have 5 factorial. Now for us to be able to get 5 factorial, that means we have to check what precedes 5 factorial, because for us to know 5 factorial, we need to know 4 factorial. So that's going to be like 5 times 4 times 3 times 2 times 1, right? For us to be able to get 5 factorial. Now, so for us to be able to do this, first we need to be sure of what is 4 factorial, what is 3 factorial, what is 2 factorial, what is 1 factorial. So 5 factorial now is going to be equal to 5 times 4 factorial, right? And 4 factorial is going to be equals to 4 times 3 factorial. 3 factorial is going to be equals to 3 times 2 factorial. And 2 factorial is going to be equals to 2 times 1 factorial, right? And 1 factorial, of course, we know is equals to 1. Now, you know, this is recursion, so it breaks down things into simpler steps for us to understand. Now, how do we then calculate our 5 factorial? First, this is 1, so 1 factorial is equals to 1. So what then happens is that this 1 is going to be pushed down here, and this is going to be 1 here, which is 1 factorial. So this is going to be 2 times 1, right? And of course, 2 times 1 is equals to what? 2. 2 times 1 is equals to 2, so 2 is going to be pushed to here. 2 is going to be pushed to here. And 2 pushed to here. 3 times 2 is equal to what? 6. What then happens? 6 is going to be pushed to here, right? 6 will be pushed to here. And then here is going to be what? Yes, this is push here. This is push here, right? So this is 6. So here is going to be 6 times 4, right? 6 times 4. And 6 times 4 is what? Is 24. 24 now is going to be pushed down here, right? 24 is going to be pushed down here. And then 5 by 24 is equals to what? 524. 524 is 120, right? So this is how to break down things in recursion. So the factorial of 5 factorial is equals to what? 120, right? So this is what we are asked to do, to write a function that returns the factorial of a given number. So if a factorial of a given number is given, we should write a function that will return the value of that given number. So that being said, let's look at our task and how to do that. Now, just the way I explained this is how it's going to work. It breaks down the factorial from the highest. So if it's 10 factorial, it's going to break it down from 10. So that's going to be 10 times 10. That's 10 equals to 10 times 9 factorial. 9 equals to 9 times 8 factorial, all the way to 2 equals to 1 factorial. And then you will sum up your results and have your total, just like we did here. Remember, in recursion, you have to stack, break it into simpler levels and stack. All right. So let's go ahead and see how we can write our function. Let's open the file name. So we'll say vi3 factorial. So let's just document. So the function name is factorial. Function name, and our parameter is n. Parameter, and let's add a return. So return a given factorial. Okay, so I think that is fine. So now let's write our code. So you can do better with your description, please. Let's write our code. Now, how do we write this? Now, you know that for us to get the factorial of a given number of 5, so 5 factorial is 5 equals to 5 times 4. So this can be written as 5 equals to 5 minus 1, which is 5 equals to 4, right? Something of this nature. So we're going to apply the same to our code to be able to get the factorial of a given number that is passed to our function. So 5 minus 1 will give us 4. 4 minus 1 will give us 3. So if we're going to write our equation, our code is going to be 5 by 5 minus 1, which the answer, of course, is 4. In this case, we are given n, so that's going to be n equals to n minus 1, right? Okay, so that is what I just want to put out there. So let's write our code. Let's set a condition. Now, from the question, they say if n is lower than 0, the function should return minus 1 to indicate an error. The factorial of 0 is equals to 1. Yeah, we know that already. So let's set a condition and say if n, which is the function parameter, is less than 0, what should happen? It should return a negative number, which is minus 1, right? It should return a minus 1. Else, if n is equal to 0, what should it return? What should happen? It should return 1. Of course, we say that the factorial of 0 is 1 from the question, so we should return 1. Else, now let's set our condition to find if it's not minus, if it's not less than 0, if it's not equals to 0, let's then find a condition that will work for us. We're going to say that if it's not equals to 0, is not less than 0, it should return, so return n times, let's call our function name factorial n minus 1. So we've done justice to this. So if it's not equals to, if it's not less than 0 and is not equals to 0, then it should return whatever number is given to it. That means if the number is 1, then it's not less than 0 and it's not equals to 0. So if it's 1 that is given to it, it should return that the factorial of that number multiplied by the factorial minus 1, which is what we stated before. So 5 times 5 minus 1, which is 5, which is equals to 5 times 4. So it should return that. So if it's 1 that is passed to it, so if it's 5 that is passed to it, it should return 5 times 5 minus 1, and it should give us the result. Let's go ahead and save this. And so I already have the test file, so let's just compile, copy this, create a test file and check. So let's compile and see, and let's run our code 3 factorial. So here you see that, let's cut our main 3 main.c and c. So here you see that we have 1, we have 120, we have this, we have minus 1. Why? What is passed here first? 1 factorial is passed and it gives us 1 factorial. 5 factorial is passed and it gave us what? 120, which was exactly what we got here, right? 120, which is 5 factorial. 10 factorial is passed and it gave us this, and then a negative number is passed and it gave us minus 1, right? So that means our code is working properly. So you can git add, git commit, and git push. Okay, so let's move to the next question. Let me open the question number 4. So question 4 says that we should write a function that returns the value of x raised to the power of y. That we should write a function that returns the value of x raised to the power of y. And then it says that if y is lower than 0, the function should return minus 1. Okay, now this is similar to what we've just done, but here the difference is that we are using raised to power. Similar to what we've just done, but the difference is that we are using raised to power. So if my x, let's say my x is equals to 5 and my y is equals to 4, right? So this is going to be 5 raised to the power of 4. Yeah? If my x is equals to 5 and my y is equals to 4, this is going to be 5 raised to the power of 4. And how do we get 5 raised to the power of 4? Just like we did in our previous example, this is going to be 5 raised to the power of 4 is going to be equals to 5 times 5 raised to the power of 3. 5 times 5 raised to the power of 3. Let me write this better. Five times 5 raised to the power of 3, right? And if we want to get this is going to be 5 times what? 5 raised to the power of 2. We want to get this is going to be 5 times 5 raised to the power of what? 1. We want to get this is going to be 5 times 5 raised to the power of what? 0. Right? And 18 raised to the power of 0, of course, is 1. Okay. Now, let's say we want to calculate this now, which is 5 raised to the power of 4. How do we calculate this? First, we're going to pass this one to this. Remember in our previous example, so this is going to be 5 times what? 5 times 1. And 5 times 1 is equals to what? Is equals to 5. So this is going to be 5. So we'll pass 5 down here. And then we look. 5 times 5 is equals to what? 25. So we'll pass it down here. 25. Right? And then we look. We'll pass 25 down. So 25 times 5 is going to be what? 25 times 5 is 125. We'll pass it down here. And then here, 5 times 125, 5 by 125 is going to be 5 by 125 is going to be equals to 6, 2, and 5. 6, 2, 5. Yep. So this is what our 5 raised to the power of 4 is going to give us, 625. So this is exactly what we are asked to do, and this is what we are going to do. To find any number that is raised to it, we should find that number. Now from our question that we were given, our question says that we should write a function that returns the value of x raised to the power of y. X raised to the power of y. So x is 5, y is 4. So whatever is given to us as x raised to the power of whatever is given to us as y. And then it says that if y is lower than 0, then the function should return 1. So let's see how we can write this code. First, let's open our file name, which is 4. So let's document Betty. So function name, yeah, make sure there's no white space after your code or after your write-up, your description. And here we have parameter x. So I'll just say parameter 1, parameter 1, and here we have another parameter which is parameter x. So sorry, y. So I will just say parameter 2, and let's just return, just so Betty is happy. So return what are we supposed to return? We're supposed to return the value of a given number passed to the function. Okay, so let's close our comment here. Okay, so let's see how we can write our code now. So it says that if y is lower than 0, the function should return -1. All right, so let's just set a condition for that, and then we'll look at how we can write our code. So we're going to set a condition that will let us know. So if y is less than 0, then it should return -1, right? Return -1. Return -1. Else, if y is equal to 0, okay, let's also set that condition. Then it should return 1. Anything raised to the power of 0 is 1. And then our final condition will now be else it should return to us x times, which is what I've just explained. So let's call the function name recursion x, comma, now we have two parameters, x comma y -1, so here is our code. So we could just say return, which is not really important. So this is a condition. If y is less than 0, then it should return -1. If y is equals to 0, of course, which is 5 raised to the power of 0, it should return 1. 10 raised to the power of 0, it should return 1. And then here we say that if not, then it should give us x times, we call the function name, which is what we did before. If not, then it should give us x times whatever the function name is, x times x, which is in this case 5, raised to the power of itself -1. Raised to the power of whatever is given to it -1. So you see here, we went past 5 raised to the power of 4. So this is 5 times 5 raised to the power of 3. That is 5 times 5 times 5 raised to the power of 4 minus 1. And 4 minus 1 is 5 times 5 raised to the power of 3. Right? So this is what we are asked to do. So let's go ahead, save, and exit. Now, copy your test file and test, and let's compile. So let's go ahead and compile our code. If everything is okay, that is fine. And let's check our code. So let's start our form.main.c and see. So here we see that this is 1 is pass, right? And then we have this. 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 So our function is working correctly. So you can check the result in your intranet. And git add, git commit, and git push. Okay, so I think here I will have to stop this video here. The remaining questions, the answers will be in the description of this video, the Google document. And if you have any question, you can send your questions across to me. And if you want to get directly in touch with me, just drop a comment and I will get in touch with you. I will let you know how you can get in touch with me. And if you're interested in being mentored in this C programming or ALX, you can also get in touch with me. Just drop a comment and I will let you know how you can get in touch with me. All right, guys, so thank you for staying till this time. Please make sure you like and make sure you share. God bless you.